Autonomous driving systems are being developed to help alleviate traffic congestion and driver shortages. Vehicles certified as Autonomous Driving Level 5 can operate safely based on information from their onboard sensors. However, sensors alone cannot reliably detect a person suddenly emerging from behind an object, making Level 5 difficult to achieve. For this reason, at Level 4, the Road Traffic Act requires the establishment of a remote control room staffed with remote operators to ensure safety. Under this legal framework, if the video stream transmitted from a vehicle becomes unclear or if transmission errors occur, the enforcement regulations of the Road Traffic Act mandate that a remote operator be notified. Despite this requirement, there are currently no standards for determining whether video delivered to the monitoring system meets the video quality necessary for effective remote monitoring. When wireless communication is of high quality, remote monitoring video can clearly capture a person jumping out from behind an object. However, when communication quality deteriorates, available network bandwidth decreases, which may lead to reduced video bitrate or packet loss. A lower bitrate degrades video quality, making it harder to recognize objects that suddenly appear in front of the vehicle. Furthermore, when packet loss occurs, video frames may freeze, making it impossible to detect such objects. As a result, it may look like a person has suddenly appeared out of nowhere. It remains unclear just how much video quality degradation or how many frozen frames cause a significant drop in object recognition. In addition, the faster a vehicle travels, the farther it moves in a given unit of time. This means that at higher speeds, objects must be recognized earlier and at greater distances. However, the relationship between vehicle speed and the ability to recognize suddenly appearing objects is also not well understood. So, NTT has developed a parametric object recognition ratio estimation model. It estimates whether the video quality is sufficient for a remote monitor to recognize suddenly appearing objects. To establish this model, we first conducted experiments to analyze the relationship between certain parameters, such as encoding bitrate, the number of frozen frames, and vehicle speed, and object recognition ratio. This graph shows how bitrate, resolution, and frame rate relate to object recognition. As bitrate decreases, before the recognition ratio for high-resolution, low-frame rate video drops, that for both high-resolution, high-frame rate video and low-resolution, high-frame rate video drops. Next, when video freezing occurs, the recognition ratio decreases as the number of frozen frames increases. Finally, regarding vehicle speed, the higher the speed, the more rapidly the recognition ratio declines as bitrate decreases. We developed this model by formulating a mathematical algorithm based on certain subjective evaluation characteristics of object recognition ratio and information about remote monitoring video. This model has been adopted as the new ITUT Recommendation P.1199. The Parametric Object Recognition Ratio Estimation model enables rapid detection of brief video freezes or quality degradation that could cause a remote operator to miss a suddenly appearing object, thereby contributing to the safe realization of autonomous driving Level 4.